Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, Signal and not forgetting the .NET Core community itself. I am your host Jamie Gaprogman Taylor and this is episode 4, just what is .NET Standard? In this episode I'll take you through what the .NET Standard is, why we need it and who is in charge of its evolution. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. If you're new to the podcast, then you may not know that I've been writing about .NET Core for almost 2 years, that is, as I record this, and it's still quite exciting to me. I'm not a Microsoft employee. I make a point of saying that at the start of each episode, by the way. In this episode, I'm going to take you through just what the .NET Standard is, why it was created, and how it relates to .NET Core. As a reminder, I do write about .NET Core over at .netcore.gaprogman.com, and I've written about the .NET Standard a few times already. If after you've listened to this episode you want to read a little bit more about .NET Standard, make sure to check the show notes for links to my previous articles on the subject, along with any other recommended URLs. If you don't know where to find the show notes, don't worry. There'll be a link in the description of this episode in your podcatcher of choice, and I'll mention the podcast website a bunch of times anyway, .netcore.show. As the .NET Standard is evolving all the time, some of the minutiae I cover in this episode may become out of date. I'll make a point of keeping a list of errata in the show notes, so remember to check them. I'll also, no doubt, be covering the .NET Standard in a later episode, so remember to check back for more episodes on it. Anyway, let's talk .NET Standard, right after this. So what is .NET Standard? Well, everything, and I mean everything that we use on a daily basis has a set of standards documents behind it. Your credit, debit, or ATM card adheres to a set of standards set up by the international banking industries, things like the physical size of the card, where the magnetic stripe is located, and, if it has one, the type of chip and NFC circuit inside of it. Have you ever noticed that most doors are pretty much the same size? How about keys? What about buses and trains? Cars too. Even the things that we don't see like power, water, cell phone signals, medical instruments, and the whole of Bluetooth and USB. There are standards which dictate how these things should work. Some countries have their own standards for things like radio waves, which frequency bands are permitted, etc., or slightly different versions of the international standards, whether to use AC or DC for power sockets, for example. The .NET Standard is no different. Back when .NET Framework was first released, one of its killer features was that it had something called the Base Class Library, or BCL. This allowed the .NET Framework to expose certain data types to us developers, things like string, double, and int, for example. This BCL was used to communicate with the Common Infrastructure, which is a collection of compilers, linkers, and runtime components. This was fantastic because it meant that you could write entire software libraries in C#, VB.NET, or even managed C++ and consume any of it using any of the other managed languages. Then along came Mono with its own BCL. Suddenly there were 2 BCLs. Then came Xamarin, and there were 3. And then .NET Core, and then there were 4 of them. I don't know whether you've ever had to support 2 different codebases for the same app. An example would be an Android app codebase in Java and an iOS app codebase in Swift. If you make changes to one, to use some new feature of your web-based API for instance, then you have to make that change in the other codebase too. Imagine doing that, but with 4 separate codebases. Then remember that each of these 4 technology stacks are at different maturity levels. .NET Framework is essentially feature complete at this point, whereas .NET Core is still evolving. And that they target completely different operating systems. .NET Framework targets Windows only, whereas .NET Core targets Windows, macOS, and Linux. What a nightmare! Especially since Microsoft now own all of those technology stacks. Meaning as soon as they want to implement a new API or feature, they need to supply many times the effort required to implement it on just one of those stacks. Then you need to think about how all of those, except for the .NET Framework, are cross-platform, and that they all use different underlying OS system calls. One of the biggest points for using .NET Framework was that you could create portable class libraries, or PCLs. This is what enabled you to create a class library in C# and have a managed C++ project consume it, and obviously vice versa. Each of the .NET ecosystem platforms, .NET Framework, Mono, Xamarin, and Core, had their own PCLs, so they were no longer portable. Along came the standard. Before we go on, I just want to talk about platforms and ecosystems. In the context of .NET, we have one ecosystem, i.e. the .NET ecosystem, and many platforms, so .NET Framework, .NET Core, Mono, Xamarin, Unity, etc. Only once you get that definition straight in your head will the rest of the documentation and discussion around .NET start to make sense. As you can no doubt tell, having 4 different PCLs created quite a difficult situation for Microsoft, a company which prides itself on backwards compatibility. They couldn't just drop an entire platform because it was too difficult to maintain. I'm not going to mention Silverlight, as this was related more to browsers and the evolution of HTML5 than anything else. So they needed to standardize it. Essentially, the .NET standard is a versioned document. At the time of recording this episode, it has versions 1.0 to 1.6 and 2.0. This lists all of the APIs, types, and namespaces that a platform within the ecosystem must support, which is a very long-winded way of saying that it's Microsoft's attempt at standardizing how cross-platform .NET APIs will work across all supported .NET platforms, including IoT and Raspberry Pi support. That's a quote from a blog article that I wrote about the .NET standard back in November 2016. Check the show notes for a link to it. The idea is to replace all of the disparate platform-dependent BCLs with one BCL to rule them all. Trademark. However, since all of the code which runs all of the different platforms is already out there and has been out there for almost 2 decades, at least in the case of .NET Framework, it can't easily be swapped out. So what's a multinational technology corporation to do, other than form a committee and figure it all out? That's where Emo Landworth and his team came in. It's their task to decide which APIs, types, and namespaces are supported by each version of the standard, and to ensure that they are indeed supported across different ecosystem platforms. There's that phrase again. In the case of platforms like .NET Framework and Mono, almost all of the APIs, etc., are supported by default. In fact, .NET Framework version 4.5 was used as the basis for the first version of the .NET standard, as it was seen to be almost feature complete anyway. But the way it works is all a bit obtuse, right? Nope. Since you're listening to this podcast, I can assume that you're interested in development. In C# we have the idea of interfaces. These allow us to describe the public methods that a class will implement by listing their signatures, and any class which implements that interface must implement all of the methods listed in the interface. It can implement more methods, but the ones in the interface must be implemented. For my C and C++ developer friends, this is analogous to how header files work. Since we know what interfaces are, we can use them as a metaphor for the .NET standard. A version of a .NET ecosystem platform, say .NET Framework 4.5, must implement everything described in the interface to .NET Standard 1.0, whereas .NET Framework 4.6.1, for example, must implement everything described in .NET Standard 2. Check the show notes for a more visual example of this in the form of a code snippet. I'm not going to read it out because you don't want to hear me reading code, but check it out because there's a bunch of interfaces that all implement each other. A more concrete example. Let's say that you work for a bank, and it's decided that the website and API for the bank needs to be rewritten and modernized. It's decided that you're going to use .NET Framework 4.6.1 to build the API, using domain-driven design and using Node.js in the front end. Then it's decided, on the day that it's released to the public, that the bank should have both an iOS and an Android app. So you decide to build one using Xamarin. During development, you copy the relevant models and business logic over to the codebase for the app. Then the bank decides that it wants to create a game, one which can be used to teach children how to save money. It's decided that the game should not connect to the real API, so you start copying over the relevant parts from the API web service and build a Unity app. By the way, I'm not saying that this is the way you should go about it, I'm just using an extremely contrived example to get the point across. When the Android and iOS apps and the Unity game are released, someone points out a bug in the service layer code. You scramble to fix it for the API to the website. Then you remember that the code in the Android and iOS app need to be updated too. Just when you think the smoke is cleared, you remember that the Unity app needs to be updated as well. Then you're told that each customer can have multiple accounts. In a previous design, it had been assumed that each of the bank's customers could only have one account. So you go back to Visual Studio and you add support for multiple accounts per customer in the API. Then replicate it in the Android and iOS apps, and finally in the Unity app. As you can see, or hear as the case may be, if each of the apps that we'd written, API, Android, iOS and Unity, used a set of common library code, in my example this would be the entities and services, but in real life it wouldn't be that simple, then issuing updates would be a case of updating the relevant DLLs and importing them back into a new build of the codebases, or perhaps you'd do them as NuGet packages. This is what the .NET Standard is all about. By targeting a version of the .NET Standard rather than a specific ecosystem platform, you're ensuring that your code can run on .NET Core, .NET Framework, Mono, Xamarin, which includes iOS, Android and Windows, Universal Windows Platform, Windows Phone, that is if you target .NET Standard 1.0, 1.1 or 1.2, or any other possible future .NET ecosystem platform. However, there is a trade-off here. The higher the version of the standard, the more APIs you gain access to. However, you end up with fewer .NET ecosystem platforms. For a visual on how this works, check the show notes. There's a table that shows it all off. Essentially, there are fewer .NET ecosystem platforms which support .NET Standard 2.0 than there are which support .NET Standard 1.0. So the higher the value for the .NET Standard, the fewer possible platforms you can target for. The table in the show notes shows the .NET ecosystem platforms as rows and the .NET Standard versions as columns. As the .NET Standard version number increases, the platform support drops off. Microsoft's official guideline when targeting .NET Standard is to target the lowest version of the standard that you can get away with in order to get the widest possible ecosystem platform target area. Wrapping up. We'll leave it there, I think. .NET Standard is a complex enough topic that both Emo and the ASP.NET team have had to think of multiple different ways to explain it. When it was first announced, members of the community started asking, how do we install .NET Standard? And very similar questions. But Imo and his team have been truly transparent about it, and he has even created a series of short YouTube videos which explain the .NET Standard. Check the show notes for a link. The .NET Standard is a point of reference for describing which APIs and namespaces which are supported in the different versions of the .NET ecosystem platforms. The ecosystem platforms include .NET Core, .NET Framework, Mono, Xamarin, and Universal Windows Platform, but can expand to include any new platform which adheres to the .NET Standard. Higher versions of the standard contain more APIs, but reduce your potential ecosystem platform support. By ensuring that your libraries target .NET Standard rather than one of the specific platforms, you can be sure that those libraries are consumable by the widest possible number of ecosystem platforms. Anyway, that's going to do it for this episode. Hopefully you found this interesting. If you did, then let me know by sending me a tweet at .NET Core blog, or head over to the website, .NETCore.show, and let me know what you think. Remember to check the show notes for a link to the full transcription of this episode and links to a bunch of related websites and resources. This is available at .NETCore.show. And don't forget to spread the word. Leave me a rating or a review in your podcatcher of choice, and come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks.